Okay, let's unpack this. Today, we're doing a deep dive into something pretty extraordinary.
It's not just another paper, is it?
No, not at all. This is a full-scale declaration, a manifesto, really. It's titled the Codex Chronos, and we're looking at the Unified Chronofractal Field Theory, or UCF, and specifically version 8.0.
And that V8.0 status is critical. The authors, Grimberg and the Nexus AEBE group, they aren't just, proposing a new model.
No, they're asserting this is an immutable canon.
That's the word they use. It's rooted in what they call geometric inevitability, or GI. I mean, from the first page, it's an explicit, almost aggressive challenge to the entire foundation of modern physics.
So the mission for us, for you listening, is to really get to the bottom of why this document is so confident. I mean, radically confident that it can just wipe away dark matter, dark energy, even solve things like the muon anomaly.
And do it all while sticking to the absolute strictest mathematical constraint you can imagine.
They kick the whole thing off with this huge critique of cosmology today.
They call it a cult of complexity, specifically the lambda CDM model, the standard model of cosmology.
A cult of complexity. I like that.
Think about it. For the last 50 years or so, what happens when an observation doesn't match the theory?
You add something new.
You never question the core assumptions. You bolt something on. It's what they call the era of parameter inflation.
Right. So a measurement from the cosmic microwave background is a little off.
Invent a new inflationary field. Galaxies are spinning way too fast.
Let's invent dark matter, a whole new type of matter that we can't see or touch.
Exactly. And when you find out the expansion of the universe is accelerating, well, just invent dark energy. Every single failure leads to a new particle, a new field, or, and this is the key, a new free parameter.
Knob you can turn.
A knob you can tune to make the model fit the data. They have this wonderfully dismissive name for it.
The disco culture of fitting.
The disco culture of fitting, as if theorists are just, behind a big soundboard twisting dials until the equations look good under the lights.
That's the core rejection then. The UCF says the universe isn't this messy database that needs hundreds of tweaked constants.
Exactly. They look at these other hugely complex attempts at unification, like Eric Weinstein's 14-dimensional geometric unity.
Which is a beautiful idea, mathematically.
Oh, absolutely. But they say, you're looking in the wrong place. The universe isn't a collection of disparate things you need to force into unity. It's actually simple, but it's folded.
Folded. And this folding idea brings us to this single, absolutely non-negotiable rule of the entire theory, the thing that makes this so fascinating.
The zero parameter limit. They call it the K0 protocol.
Explain what that really means, because it sounds impossible.
It's the most revolutionary constraint. It says if the universe really does follow a simple geometric blueprint, then every single observable constant you can measure.
The strength of gravity, the rate of expansion, the mass of an electron.
All of it, every single one, has to be a pure mathematical derivation from just two fundamental geometric axioms. No exceptions. You can't use fudge factors, you can't tune anything, you can't have variables that you fit to the data.
I have to press you on that. I mean, isn't that just an incredibly reckless, almost arrogant posture for a scientific theory?
It's the ultimate display of confidence, but you're right, it's also a profound vulnerability. It is an immutable canon. So, for instance, if the UCF predicts that the total mass energy density of the universe must be X,
and a new satellite measures X plus, say, 5%.
the whole thing collapses. The entire edifice, the dark matter replacement, the dark energy derivation, the quantum stuff, all of it, it's gone.
So any small deviation just flips a kill switch.
Yeah.
Instantly.
Precisely. They are staking everything on this absolute belief that the truth is revealed in 3 spatial dimensions, plus a really subtle but critical tweak to the nature of time. They say if the geometry is fundamental, it has to be universal and exact. All the complexity we see is just emergent.
Okay, then let's get into that geometric blueprint. The whole theory is apparently unified by just 2 numbers, nu and pi.
Right. And we have to start with their redefinition of time and mass, because that's where the first constant, nu, comes in.
And this is where they just throw dark matter and dark energy right out the window.
Completely dismisses them as physical things. They argue they aren't particles or fields we need to find. They are artifacts, ghosts in the machine caused by a faulty counting process in lambda CDM.
Errors in how we measure time and space.
Specifically. And the first, most radical correction they make is to define what they call the engine of time.
The engine of time.
Yes. So Axiom 1, it states that the universe is not some static block of space that just, expands. It's a continuously evolving self-referential process, like information crystallizing.
Okay, self-referential process.
And the rate, the scaling of this process, is governed by a very specific mathematical constant, a renormalization group fixed point.
Which just means the system naturally settles on an equilibrium growth rate.
Right. And they define that growth rate with an incredibly simple equation. Nu squared plus nu minus 1 equals 0.
Anyone who's studied mathematics will recognize that. It's related to the golden ratio.
It is. When you solve that equation, it gives you the golden ratio conjugate. So not phi, but its inverse nu, which is about 0.6180339. This one number, they claim, is the core fractal signature of all cosmic evolution.
So how does a fractional number like that change something as fundamental as time?
It means time isn't the straight, linear, one-dimensional arrow we all imagine. It has a fractal dimension. The dimensionality of time, d sub t, is 1 plus nu.
1 plus 0.618.
So you get this tiny excess dimensionality, this 0.618. And that little bit of extra fractal dimension, they argue, creates a continuous negative pressure throughout the vacuum of space.
Wait a second. You're telling me that dark energy, this mysterious force that's accelerating the expansion of the entire universe, is just the pressure being exerted by time itself being a tiny bit more than one-dimensional?
That is the assertion. That's it. Dark energy is not some exotic scalar field we need to hunt for with a satellite. It is the geometric necessity of time growing. Time isn't just expanding in length, it's expanding in its own complexity.
That is a wild idea. And it leads right into the core philosophical change here, what they've called the Fibit revolution.
It does, because if time is fractal and it's generating this pressure, what does that mean for gravity?
Okay, what does it mean?
The central dogma of the UCF is this. Gravity is not a force, it is memory.
Gravity is memory.
The reason massive objects attract each other, they argue, is because mass carries history, and that history has weight.
That's a powerful metaphor.
Yeah.
It's very poetic. But how on earth do you quantify memory? You can't just put that in an equation.
Well, they do. They introduce the fibit. The symbol is a fib with bit as a subscript. The fibit is the thermodynamic unit of history.
Okay, a thermodynamic unit of history.
It's an information metric that goes way beyond a simple Shannon bit, like a 0 or a 1. It tracks information not just in its quantity, but in its persistence across this chronofractal background.
So if a normal bit is a switch that's either on or off, what is the mathematical definition of a fibit?
They call it the fractal information unit, or FIU. One fibit is equal to one standard bit of information multiplied by 1 gigayear raised to the power of nu.
So the age of the system is a critical component.
The logic is that information has mass, and that mass scales with the nth power of the system's age. So as a system, a star, a galaxy, as it ages, it doesn't just gain linear time, it gains what they call chronofractal information density. It accumulates fibits.
So the gravitational pull of an object is less about its mass right now and more about its total accumulated history.
Exactly. Let's say you have a hard drive. A standard gravitational model is like measuring the weight of the data on the drive right now. The UCF model is like measuring the cumulative history and evolution of the hard drive itself over cosmic time. That accumulated weight of time, the fibit density, is what sustains the gravitational potential.
And this is their direct replacement for dark matter. The missing mass in a galaxy isn't a halo of weird particles.
It's the literal weight of the galaxy's own history.
That's a lot to take in.
It is.
Yeah.
And the test case they use to really hammer this point home is what they call the gas-vacuum paradox. They specifically point to the galaxy NGC 3838.
Tell me about NGC 3838. What makes it such a problem for the standard models?
It's a very old, very gas-poor, early-type galaxy. So it's lost most of its visible, fast-moving gas. Now, if a theory like M-O&D modified Newtonian dynamics, or just standard baryonic physics were right,
then a galaxy that loses its gas should slow down.
right,
The rotation curve at the edges should just plummet.
it should fall off a cliff. But it doesn't. NGC 3838 maintains this surprisingly robust, high-speed rotational field, even with almost no gas out there.
For a dark matter model, that's easy. You just say the invisible halo is still there. Who cares about the gas?
Of course. But for any model that relies only on what you can see, it's a huge, huge problem.
So how does the UCF explain it?
Under this new framework, the solution becomes obvious. The gravitational field isn't being sustained by the instantaneous gas mass, which is close to 0. It's sustained by the historical information density, which is the age, tau, raised to the new power.
So the galaxy has existed for billions of years. It's been accumulating phambobits. It's reached a high historical saturation.
That's the term they use. The rotation curves reflects the memory of the mass that used to be there and the memory of space-time itself warping over that long fractal duration. It's not about the meager gas that's present right now.
The gravity holds because the history holds. A galaxy rotates fast because it's old and its geometric memory has matured.
Yes, and that fundamentally changes how we have to think about cosmological timescales.
And that idea of chronofractal evolution is the perfect bridge because it takes us from a single galaxy's rotation to maybe the biggest crisis in cosmology right now, the one created by the James Webb Space Telescope.
It's the logical next step. JWST has been giving us these just stunning images of galaxies at incredibly high redshifts.
Meaning we're seeing them as they were when the universe was very, very young.
Extremely young. And what JWST found that was so upsetting to the standard lambda CDM model
Was that these galaxies were too good, too mature.
Exactly. It found fully formed, massive, mature spiral galaxies. They had well-defined bars, organized structures. According to standard cosmology, at a redshift of z equals 10, only about 450 million years had passed since the Big Bang.
And that's just not enough time.
It's not nearly enough linear time for these huge structures to pull themselves together, cool down, form complex star populations, and settle into these beautiful spiral shapes. They are chronologically impossible. They shouldn't exist.
The UCF, in the document, calls this the linear time illusion.
Right. We assume time has just been ticking along like a metronome, 1 second after another, everywhere in the universe at the same rate. But the geometry says no.
The K0 axiom, the zero-parameter rule, dictates that time has to be a fractal dimension, and it has to scale with nu.
So the denser the early universe was, the more rapidly proper time was actually accruing from a geometric standpoint. And this leads them to the chronofractal correction formula.
Okay, let's break that formula down. It looks simple on the page, but the implications are staggering.
The effective structural maturity, which they call TOEF, is corrected at these high redshifts by using the new constant. The formula is the effective time is the standard lambda CDM time multiplied by 1 plus the redshift, all raised to the power of nu.
So what that's saying is that the local matter in the early universe, where things were much denser, was actually experiencing a geometric expansion of its own proper time.
It got a time acceleration. It had more time to work with.
The geometry literally gave these young galaxies a head start. They were aging faster than the universe as a whole.
Exactly. And let's use a specific example they give in their redshift mapping table, Table 1. At redshift Z10, the raw linear lambda CDM age is 450 million years. That's the standard clock.
Okay.
But the UCF calculates this boost factor. You take 1 plus 10, so 11, and you raise it to the power of nu, 0.618. That factor comes out to about 4.41.
And so you take the 450 million years that standard cosmology gives you, and you multiply it by 4.41.
And suddenly, the effective historical duration that this local patch of matter has experienced jumps from 450 million years to almost 1.98 billion years.
Nearly 2 billion years.
Which is more than enough time for a complex spiral galaxy to form, for massive stars to live and die and enrich the environment with heavy elements. The paradox is gone.
So the impossible early galaxies are resolved, and not by adding new physics or exotic particles.
But just by acknowledging that time is fractal. The universe doesn't have hidden age, it has hidden geometry, and it's hidden in the dimension of time itself.
It's elegant. I'll give them that. The simplicity is key. It sticks to that K-year rule. Okay, so we've used nu to fix the universe's history. Now let's use it to predict its future. The whole business of dark energy and the equation of state, which is just labeled with the letter W.
Right. Standard cosmology sees this accelerating expansion, but it treats the cause, dark energy, as this total unknown. It's a mysterious scalar field.
But the UCF says it's not a field at all.
No, it's just a necessary property of the fractal time dimension, nu. This is what they call the third balance, and they mathematically derive the exact parameters for the equation of state, nu, no, not, and WA from pure geometry.
Without looking at any supernova data, because that's how W is normally measured.
Without any data at all. This is the zero-parameter requirement in its purest, most audacious form. They have to derive a cosmic constant from scratch, using only nu.
How do they do it?
They start with the base state, nu naught. This represents the constant isotropic pressure that's generated by this fractal time dimension nu as it tries to distribute itself across the 3 spatial dimensions.
So the division by 3 is literally just spreading the pressure out over X, Y, and Z.
That's all it is. So if time is creating this geometric pressure with a magnitude of nu and it's spreading out equally in three directions, the resulting equation of state just has to be ρ naught equals -1 plus nu divided by 3.
The -1 is what you'd expect from a simple vacuum energy, like a cosmological constant.
Right, but the geometric excess, this nu over 3 term, dictates the deviation from that perfect constant.
So if you plug in the number for nu, about 0.618, you get ρ naught equals -1 plus about 0.206.
Which gives you ρ naught is approximately -0.794.
And that is a massive prediction.
Yeah.
Because lambda CDM absolutely requires dark energy to be a perfect cosmological constant.
Sure.
It demands that ρ naught equals -1.
Exactly. I mean, UCF is predicting a dynamic thawing dark energy. It's not constant at all. And they don't stop there. They also predict the evolution term, WA, which is how W changes over time.
Right.
And that's governed by the second-order scaling term, nu squared. This term represents the kinetic or the evolutionary aspect of the fractal growth. And again, it's just distributed across the 3 dimensions. So the prediction is WA equals nu squared divided by 3.
Which calculates out to about positive 0.127.
And this pair of predictions, the W naught and the WA, is huge because it sits smack in the middle of the high likelihood statistical contours from the latest data from instruments like DEA, the Dark Energy Spectroscopic Instrument, and the Planck satellite.
They aren't fitting their theory to the data.
The data is confirming their geometry. And this is where that vulnerability, that kill switch, comes right back in. The final test, the moment of truth, will be the super high precision measurements we expect from the Euclid mission.
Which is scheduled for 2026.
The stakes could not be higher. If Euclid sends back data that says nu naught is -1.00 exactly,
The UCF geometry is falsified, the kill switch is thrown, the theory dies.
but if Euclid measures a value around -0.794, it would be overwhelming evidence that we aren't measuring some weird, mysterious energy field. We are simply measuring the mathematical necessity of time flowing fractally in 3 dimensions.
Okay. We've used the time axiom, nu, for everything so far. Now we have to bring in the second geometric actor in this play, the topological axiom, pi.
Right. If nu governs flow and expansion, pi governs boundaries and limits. It dictates how information is diluted in space.
So axiom 2.
Axiom 2 states that the way information density spreads out in the vacuum is intrinsically regulated by the topology of a 3-sphere. Information doesn't just spread out infinitely, it gets topologically damped.
And this regulation gives them the topological damping identity.
Yes. A new constant they call eta, which is just defined as 1 divided by pi, so about 0.3183. This is the factor, they claim, that constrains field memory, limits the energy available in a system, and dictates how much influence things like gravity can exert.
And what's really remarkable, but so hard to believe, is that this one constant, 1 over pi, just starts popping up across this unbelievable range of scales. Let's start at the very, very beginning. The first joule of validation, they claim. The cosmological lithium problem.
This has been a headache for decades, one of the longest-standing crises in particle cosmology. The theory of Big Bang nucleosynthesis, BBN, is otherwise incredibly successful. It predicts the primordial amounts of hydrogen, helium, deuterium almost perfectly.
But not lithium-7. That's the one outlier.
The big one. The theory predicts that the universe should have a lithium-7 abundance of about 5 times 10 to the -10 relative to hydrogen. But when we look at the oldest, most pristine stars, the ones that should reflect the composition of the early universe, we consistently see a huge deficit.
How big a deficit?
We only observe about 1.6 times 10 to the -10. It's a massive 5 sigma statistical tension. We're missing 2/3 of the lithium that should be there. And standard nuclear physics just cannot explain it without resorting to some really complex ad hoc reactions.
So what's the UCF solution?
They bypass nuclear physics entirely. They argue that the primordial universe in the first 3 minutes was a geometrically closed system, and the energy that was available for creating fragile isotopes like lithium-7 was topologically limited. The total effective energy density was damped by this factor 1 over pi.
So you're telling me they just apply that topological damping identity 1 over pi directly to the standard BBN prediction?
That's the entire calculation. It's stunningly simple. The UCF prediction for lithium is just the BBN prediction for lithium multiplied by 1 over pi.
So 5 times 10 to the -10 times 0.3183.
And what do you get?
What's the result?
It's 1.5915 times 10 to the -10.
That's an almost perfect match. The observational mean is 1.60.
It is an exact tac recheck T, as they put it. The crisis is resolved geometrically. The very shape of the vacuum, regulated by pi, was dictating nuclear chemistry at the birth of the cosmos.
The idea that pi isn't just a constant for circles, but a universal constraint on how energy can even manifest. That's profound. So now let's jump. Let's jump 40 orders of magnitude, from the atomic nucleus all the way out to our solar system for the second jewel, the Pioneer anomaly.
Right, the Pioneer 10 and 11 spacecraft. After they flew past all the major planets and were just coasting out into interstellar space, they started exhibiting this very subtle but persistent, unexplained acceleration.
They were being pulled back toward the sun.
By a tiny constant force, an acceleration of about 8.74 times 10 to the minus 10 meters per second squared.
And NASA spent years, decades, chasing this. They tried to blame it on thermal radiation from the craft's power sources.
The RTGs, yeah. But the thermal models were never a perfect fit. They always required some tuning, some adjustment. It was never a clean, zero-parameter solution.
UCF says it's not the spacecraft. It's the geometry of space-time itself.
It's a localized geometric effect. They call it Hubble drag. The idea is that the overall expansion of the universe exerts this tiny background acceleration everywhere, but that background effect gets amplified inside a local, spherically bound system like our solar system.
Why does it get amplified?
Because the local geometry imposes that same damping factor, 1 over pi. But since you're observing the field across a three-dimensional spherical boundary, the effect gets modulated by the ratio of a sphere's surface area to its cross-section area.
Which is 4 pi squared divided by pi squared.
Which is just 4.
Yeah.
But it's damped by pi, so you get a geometric factor of 4 over pi.
Ah, so you get this scaling coefficient of about 1.273. And this transforms the background Hubble acceleration into something you can actually measure locally.
Precisely. And that allows for their zero-parameter derivation. The Pioneer acceleration, according to UCF, should be the speed of light times the Hubble constant times 4 over pi.
And when you plug in the accepted values for c and the Hubble constant, what's the prediction?
The derived value is approximately 8.66 times 10 to the minus 10 meters per second squared.
And the NASA measurement was 8.74.
The prediction of 8.66 is well within the 1 sigma error margin of the measurement.
So it's a perfect fit.
It is.
Yeah.
The Pioneer anomaly, they claim, wasn't a flaw in spacecraft design. It was the first direct measurement of geometrically modified Hubble expansion right here in our own solar system.
The same pi constraint that was limiting lithium formation 13 billion years ago is subtly steering our space probes today.
The scale invariance is genuinely breathtaking.
So we have a universe governed by these two simple numbers, nu and pi. Let's try to synthesize all this into what the authors call their main achievement, the quintuple crown.
This is really the critical juncture. The quintuple crown is their argument for statistical impossibility. The idea that a geometric system using only nu and pi, with no free parameters, could accidentally resolve 5 of the biggest crises in physics.
Across 41 orders of magnitude, from the quantum scale all the way to the Hubble horizon.
The odds are just astronomical.
Let's start with crown 1, which is maybe the most contentious claim in the whole document, the complete replacement of dark matter.
Yeah, for my entire career, the flat rotation curves of galaxies have required us to hypothesize these massive, invisible dark matter halos to hold them together gravitationally.
And the UCF master equation, this chi of m and tau, it doesn't even have a term for a dark matter halo.
There's no variable for it. It calculates the gravitational potential, chi, based only on the baryonic mass, m, and the accumulated chronofractal memory, tau.
And the equation ties them together with this very specific scaling factor, m times tau to the nu times m over m naught to the minus 1 over pi power. Both axioms are in there, working together.
What that formulation means is that the scaling of a galaxy's velocity depends entirely on fractal time growth from nu and topological damping from pi. And to prove this, they conducted what they call the SPARC audit.
So the SPARC audit, what is that? It's a database of galaxies, right?
It is. It's a database of about 175 well-mapped galaxies. We have very good data on their rotation curves and their distribution of visible matter stars and gas.
So what was the methodology? What did the UCF team do?
They used their master harvester software, and they analyzed the baryonic mass distribution alone, and then compared the UCF's purely geometric prediction for the rotation curve against the actual observed velocities.
And the result?
An astonishing one-to-one correlation. They achieved a correlation coefficient, an R value, greater than 0.92. That is the same level of predictive power that dark matter models have.
But without adding a single gram of extra invisible mass.
Not a single parameter. So their claim is that dark matter is entirely an artifact of us misinterpreting this chronofractal memory saturation.
And they say the geometric rigidity of this system is proven by the scaling exponent itself.
Yes. Their analysis shows that the velocity of rotation is proportional to the baryonic mass, m, raised to the power of about 0.341.
And that number, 0.341, connects directly back to the second axiom to pi.
It does. It's almost exactly 1 over pi, which is about 0.318. It's confirming that the rotation speed of a galaxy is fundamentally dictated by the limit imposed by spherical topology in 3D space, not by some invisible halo. The universe is telling us its rules through its own shape.
That is profound. Okay, we've covered the macro, the cosmological, but the true test of any unified theory is if it can bridge the gap all the way down to the quantum scale. So let's jump to Crown 5, the Muon G2 anomaly.
This is probably the biggest experimental crisis in physics of the last decade. The Muon G2 experiment measures the muon's anomalous magnetic moment. It's basically how this unstable little particle wobbles as it flies through a magnetic field.
And that wobble is affected by all these fleeting quantum particles that pop in and out of the vacuum around it.
And the standard model of particle physics can predict that wobble with incredible precision.
But it got it wrong.
It got it wrong. When Fermilab released their high-precision results, they found a massive 5.1 sigma tension between what the theory predicted and what they actually measured. The muon was wobbling more than it should.
And the standard interpretation of that was
new physics. This was the moment. Theorists immediately pointed to supersymmetry, this whole suite of new, heavy, unseen particles that must be popping into the quantum foam for a split second and giving the muon that extra little nudge.
So physics was ready to invent, what, a dozen new particles, a dozen new fitted parameters to account for this one anomaly?
At least. But the UCF solution is geometric folding.
Geometric folding.
They say the error isn't in the particles. The error is in our assumption about the geometry of the vacuum itself, specifically in the part of the calculation called the hadronic vacuum polarization, or HVP.
So how does the geometry of the vacuum create this error?
The vacuum is modeled as a three-dimensional manifold that is intrinsically folded back on itself. So if the geometry is confined to 3 dimensions and it has to be self-referential, it introduces a volumetric suppression factor on any virtual particles trying to move through it.
Because it's a 3D manifold, the suppression factor is based on the cubic volume.
Exactly. The geometric folding reduces the effective space available for these hadronic loops to form. The suppression factor is the inverse cubic volume, 1 over 3 cubed, which is 1 over 27.
The GF127 limit.
They call it the GF127 limit, and that factor is a pure geometric necessity. It has nothing to do with the muon data. It's just a consequence of living in 3 dimensions.
So instead of inventing a dozen new particles, they just apply this one, 0-parameter geometric scaling factor, 127, to the part of the standard model calculation that was causing the problem.
That is the entire solution. The leading order HVP contribution is calculated to be about 600 and 845 times 10 to the minus 11. You multiply that by 1 over 27. The UCF-derived correction to the discrepancy is about 253.5 times 10 to the minus 11.
And the measured experimental discrepancy, the one that caused the 5.1 sigma panic, was 251 times 10 to the minus 11?
It's less than a 1% deviation. It's another exact HIT. Geometry, based only on the number of dimensions we live in, resolves a massive quantum anomaly that was supposed to require a whole new zoo of particles.
I just have to pause here. This level of scale invariance it forces a huge philosophical shift. We've talked about gravity, cosmic age, expansion, the atomic nucleus, galactic speed, and now quantum uncertainty. And it's all apparently explained by 2 geometric constants, nu and pi, under this insane K-Clausiran constraint.
It forces you to confront the difference between what theorists have been seeking, geometric unity, and what this paper proposes, geometric inevitability.
Okay, what is the core difference there?
Geometric unity is the idea that we, the theorists, have to build some beautiful, grand structure, often in 14 or 26 dimensions, and then we have to kind of force all the messy parts of reality to fit into it. It's a top-down imposed unification.
In geometric inevitability.
It's the realization that the pieces only fit one way. It's driven by the constraints of nu and pi. It implies that all this complexity is emergent, but the underlying rules are just minimalist and axiomatic. The universe isn't waiting for us to figure out how to unify it. It simply is what it is because the geometry left no other choice.
It was inevitable.
Mathematically inevitable.
And this mathematical rigidity, it leads to real physical constraints that can replace the kind of loose, fuzzy limits of the older models. And one of the most critical is this analytically derived absolute speed limit for galaxies.
Yes, what they call the Krupp-Steele limit of the cosmos.
Krupp-Steele.
In standard models with dark matter halos, you have to run these massive complex simulations to make sure the halo is dense enough to stop the galaxy from spinning so fast that it tears itself apart. It's a complicated heuristic break.
But the UCF proposes a simple, fixed speed limit. Derived from first principles.
Exactly. This derived threshold replaces that entire dark matter braking mechanism. The maximum stable rotational velocity, v-crit, is derived by combining the speed of light, c, the fine structure constant, alpha,
which governs electromagnetism,
and the fractal time constant, nu. The formula is v-crit equals 1/2 times c times alpha times nu cubed.
The presence of c and alpha there shows that this limit is rooted in relativistic energy conservation.
Deeply. And it's constrained by the geometric flow of time, nu cubed. The 1/2 is just the standard virial coefficient for a stable gravitational system.
So what's the number? What velocity does that produce?
When you plug those constants in, you get a specific velocity of approximately 258.4 kilometers per second.
And is that fast in astronomical terms?
It's remarkably high speed, but it aligns perfectly with the empirical maximum speeds we actually observe for stable spiral and elliptical galaxies. This derivation proves that the speed limit isn't some arbitrary property of a hidden halo. It's a direct, zero-parameter consequence of energy conservation in this geometric metric. The geometry itself protects the galaxy.
And this speed limit, it directly feeds into their preliminary confirmations of the 6th and 7th crowns, which they say further solidify the theory.
These are their future horizons. Crown 6 is the resolution of the fast bar paradox.
Okay, galactic bars. The straight structures of stars in the center of some spiral galaxies, they rotate way too fast. What?
Because in the standard model, the dense dark matter halo is supposed to act like a viscous fluid. It should create drag. It should break the bar's rotation. But we see them spinning incredibly fast.
And in the UCF model?
There is no halo. There is no break. The UCF geometry naturally predicts the high observed rotation speeds. The paradox just vanishes.
And Crown 7, the S8 tension, that's about the large-scale structure of the universe, right?
Right. Our cosmological measurements consistently show that the universe is smoother, meaning less gravitationally clumpy than lambda CDM predicts. The S8 tension is the parameter that measures this clumpiness. Lambda CDM predicts a little too much gravity pulling matter together.
So where does the UCF get its smoothing effect from?
From pi, the topological axiom. That damping factor, eta, which is 1/pi, it doesn't just work on the nuclear scale. It introduces a subtle geometric smoothing effect on gravitational clustering over cosmic scales. This small universal geometric limitation just naturally limits how lumpy the universe can get, resolving the tension.
So we are moving from a science where you measure something and then build a model to fit it, to an axiomatic science where the geometric rules are known in advance.
The authors call it moving from the era of fitting parameters to the era of exogenous physics, predicting reality from first principles. They have this great line. They say, if Leonardo da Vinci were alive today, he wouldn't be building particle colliders to search for invisible things.
He'd be drawing the golden ratio, nu, over a picture of a spiral galaxy.
Recognizing the blueprint that's already there in the geometry.
The Codex Chronos is open. The geometry holds.
And its greatest strength is that profound vulnerability. That strict all-or-nothing K0 protocol.
Which brings us right back full circle to the ultimate kill switch. The one single measurement that can validate or completely falsify this entire incredible structure.
The high-precision measurement of the dark energy equation of state parameter, not, from the Euclid mission, around 2026.
So if the universe is perfectly described by the standard cosmological constant, lambda and lambda CDM, dark energy will measure W0 equals minus 1.00. Exactly. If Euclid confirms that perfect constant.
The UCF geometry fails, the entire system is discarded, just as the K0 protocol demands.
But if the observation confirms the geometric necessity that they derive from the fractal time axiom, if it measures dou0 is approximately minus 0.794.
Then every single assumption that physics holds about hidden mass, hidden energy, and hidden age has to be thrown out. Overnight. It would confirm that reality is fundamentally driven by just two numbers, Nu and pi.
And it requires you to consider this. Are we really observing forces and particles and mysterious energies, or are we just finally learning to read the mathematics of space-time geometry? The geometry determines the reality, and that's the ultimate provocative thought for you to mull over. We'll see what 2026 brings.